Good afternoon, everybody. Welcome to another exciting afternoon of Chem 1105 with your host, me, Dr. White. Hi, everybody. By the way, I feel so good. My heart feels so good. Everybody did so good on test 3. Thank you. By the way, historically, after people do not so good on test 2, they always come back and do good on test 3, and you people did the same. But before I talk about that, let me give you a game plan for today. First of all, I'm going to talk about some announcements. Then I will go over the answers for test number 3, but I'll remove it from the video. I like my special effects. Click, click, click. But anyways, but I will post it as a private video and send you the URL for that video. Then, let me look at my list. We'll go over chapter 7, acids and bases, problem set, and then we will finish organic chemistry. Now, couple things tomorrow. I will go through the review for test number 4. Wait, I get this finger fixed for test number 4. And also I'll continue and finish up organic. And on Wednesday, I'll go through the organic problem set. And Thursday, we'll do test 4, and I'll also do chapter 11 and other stuff. Oh, we got a busy week ahead of us. I better get to work. All right. On your screen, I talked about this last week, but I want to talk about it again now. You see the test number 4 information. Test number 4 will be this Thursday in my class in the summer. July is Thursdays are not a fun day because all the tests I have to give. But anyways, you people are doing great. So I know you'll do great on this too. All right. This Thursday, I'll be giving test number 4 online. You'll be downloading the password protected file from the assignment area Blackboard. On Thursday, about 8 a.m., maybe even a little earlier, I'll send out an email with the password. Oops, this should be test number 4, not 1. Did I miss that? Well, you can get another email. Now I'm going to correct it. Let me keep it in there. You'll have until Friday, 4 p.m. to finish test 4 and upload your answers as a single PDF file, the assignment area of Blackboard. It should take about 40 minutes, maybe even 35 to actually finish the test if we were face-to-face, but take up to 3 hours. Hey, I'm not going to stand there with a stopwatch. But anyways, test number 4 will cover acids and bases chapter from chapter 7 and the chapters on organic chemistry. It has 17 problems, 9 pages, no multiple choice, but some of the questions are multiple part A, B, C, and so on. I have 56 points on acids and bases, chapter 7, and 49 points on organic chemistry. And that adds up to 105. So there's 5 bonus points. You'll need a scientific calculator, and I reserve the right to subtract up to 50 points. Excuse me, for anyone who does not follow instructions or don't upload your test number 4 answers on time. By Sunday, 1 p.m., this coming Sunday, I will have your scores on Blackboard. I'll put out an email to that. And I'll also, by that time, give or take a half hour, I'll send out an individual email to each of you, like I did on test 1, 2, and 3, which each point you receive for each answer you put on test number, in this case, 4. On a week from today, I'll go over test number 4 answers in our Zoom meeting, but I'll cut it out of the video and upload it as a private video. This Tuesday, like I said in my here, I'll do a review for test number 4 material. And like I said, you're going to get another email now. All right, that's test number 4. Let me remind you, a number of you have not handed in all of your labs. And because of that, and it's happened for some reason with the home lab kits, people don't do it. Anyways, I'm offering a lab amnesty. You'll have until August 1st, 11:55 p.m. by the really end of the day on Tuesday, a week from tomorrow, to get all the past labs you haven't done uploaded to Blackboard. After that time and date, I will enter a 0. Yes, a big 0, a 0 for any lab that was due but not submitted for grading. And finally, while we're here, let's go student view. Let's go to assignments. And here we have the assignment, the extra credit project. Remember, the deadline for this is August 1st, the due date. I will not accept late projects. This is optional. This is also not a group project. And what is that project? And the project is to create a table with 10 different molecules, 5 of which have to be ionic and 5 have to be only covalent molecules. You need to have the product, the name of the molecule in that product, and is it ionic or covalent, the bond type. Now, you cannot use gasoline, water, sodium bicarbonate, carbon dioxide, ethanol, also known as ethyl alcohol, sugar, which is also known as sucrose, I should have that up there, or sodium chloride, oxygen gas, nitrogen gas, or natural gas, also known as methane, which means you can't use air because that's oxygen, nitrogen gas. Now, the important thing, ingredients must appear on an ingredients list. You can't say, oh, I have an apple. This chemical is in there, and I'm going to use that on my table. No, I have never bought an apple, pear, banana, or any other fruits or vegetables that have ingredients labels on it. Now, here's a special gift. Don't tell anybody I'm being nice, but before the project is due next Tuesday, if you want, before you upload your answers, remember it's optional, but it's 10 points. It's like getting 10 more points on a test or the final. It helps. Before you do that, send me an email with your project. I'll review it. If there's anything wrong, I'll get back to you by email so you can fix it. And if you take your time, it should be no problem to get 10 bonus points. Let's show how easy it is. Great product. I use it all the time in the winter. And if you look on here, it says phenol, covalent. You can use this. But there's 2 others you can use on here that are covalent. Wow, that's 3 points already. Don't tell anybody I helped you out. Shh. Okay? So it's in your own best interest to send me before you upload it, your project, if you're going to do it, and I can check it and tell you to correct things. All right. I think we're all up to date now. Any questions before I move on? We got a full house today. All right, let's go through Test number. Now, all of you should have the following question. What grade am I getting right now? Well, let's think about that. Now, this is assuming you've handed in all your labs. Hint, hand in the labs. Let's calculate y, which is the sum of 3 tests divided by the number 3. And if y is greater than or equal to 90, you're getting an A. Y is equal to 80. Hold on, that's an awful looking 80. Sorry about that. That's better, 80, 89. You're getting a B. Y is equal to 70 to 79. You're getting a C. Y is equal to 60, 69, D, and Y is less than or equal to 59, you're getting an F. And I hopefully nobody are in the last two. But this is assuming you're handed in all your labs. Now, there's a method B. And Z is the sum of your two highest of the 3 tests divided by the number 2. And if Z is greater than or equal to 90, you're getting an A. Z equal 80, 89. B, Z equal 70, 79. C, Z equals 60, 69. D. And finally, Z less than or equal to 59. F. Now, this is assuming you've handed in all your labs. Labs are important points. If you didn't hand in 5 labs, you've just lost 50 points. That could drop you 1 or 2 letter grades. Hand in your labs. Remember, lab amnesty is good only till August 1st, the end of the night. So hand in your labs. All right, any questions? Going once, going twice. Time to move on. All right, let's look at practice problem, chapter 7, acids and bases. Remember, this is in the folder in Blackboard, cleverly labeled practice problem answers. And you should know, what is an acid per Bronsted-Lowry theory of acids and bases? It's a proton, or you can write out proton as H plus donor. An acid is a proton donor. What is a base per Bronsted-Lowry theories of acids and bases? And that's a proton acceptor. Now, you should be able, based on a formula, of a number of acids and bases. Which of the following are acid, base, or I also threw in, to make it interesting, a salt. And HCl is a proton donor, hydrochloric acid. NaOH, sodium hydroxide, proton acceptor, it's a base. Sodium chloride, it's salt. And H2SO4, it's an acid. Finally, ammonia, well, not finally, second to finally, ammonia, NH3, it's a proton acceptor, a base. And nitric acid, HNO3, I just gave it away, is an acid because it's a proton donor. You should know how to do this. All right, a solution has the hydronium ion concentration, that means H3O plus in brackets, 1.0 times 10 to the minus 3. What is the pH of that solution? And is it acidic, basic, or neutral? So we're trying to find the pH of number 4. And the hydronium ion is 1.0 times 10 to the minus 3. Let me direct you. Important, oh, my eye itches, excuse me. Really itched. All right, important information. pH is minus the log of the hydronium ion concentration, H3O plus. But my special gift to you is, don't tell anybody, if the hydronium ion concentration is 1.0 times 10 to the minus X, then the pH is X. Now, one thing, it's probably one of the most important things you will learn this semester, which you should memorize, I will not put it in important information, is the pH scale. And at 7 pH, you have a neutral solution. Anything below 7 is acidic. Anything above 7 is basic. And I haven't been subtle all day, so I better be subtle right now. And that is of all the things I'll teach you this semester, this is probably one of the most useful you'll use the rest of your life. All right, let's go back to the problem. I'm not the problem. I hope I'm not. Let's try that again. All right, so we're trying to find pH. We're given what the hydronium ion concentration. Here's the pH minus log hydronium. Put in the hydronium ion concentration, 1.0 times 10 to the minus X. The pH is X. In this case, X is 3, not minus 3, 3. And that's acidic because it's below 7. And if we look at 5 and 6, same type of problem. Now, 8 points, if I were to put this on a test, the other was 6. If a solution has a hydroxide ion concentration times 10 to the minus 3, what is the pH of the solution? And is it acidic, basic, or neutral? Now, what are you being asked to find? pH. What are you given? Hydroxide, 1.0 times 10 to the minus 3. And important information, as I have your note, you'll know pH equal minus the log of the hydronium ion concentration. Wait a second. We weren't given this. We were given hydroxide. What do? We do 2 steps. And the first step, you convert hydroxide concentration to hydronium ion concentration. Second step, hydronium to pH. Now, how do I go start this? Well, you look at important information, test number 4, and the hydronium ion concentration equals or times the hydroxide equal 1.0 times 10 to the minus 4. This is called the ionization constant of water, abbreviated KW after me. I only wish. But yes, my initials are KW. Time for a personal story. I don't think I've told you this. Many, many years ago, when I came back from grad school to Chicago, I decided, well, how do I meet people? I didn't know a lot of people when I came back 5 years after I left the area. I knew some, but where I actually lived in Chicago. And so I decided to join the Democratic Party of Chicago. And I worked for them as a precinct worker and a precinct captain. And I helped one state rep get elected. I really helped, was active on his committee. And I had probably the worst job, at least he thought so. After he won, he said, "How can I help you?" I said, "Well, you can give me some money." He said, "No, would you like a job with the state or city?" I said, "No, I have a nice job at this chemical company." He said, "Well, what can I do?" "I don't know. What can you do for me?" He said, "I'm on a state committee and this committee in the House that we're going to announce soon about this new program called vanity license plates. I can get you one of the first in the state of Illinois." I said, "That sounds like a good thing." And I talked about it with my family, and I was going to get KW. And my sister said, "You got a PhD, flaunt it." And my license plate number is DR KW from ionization constant of what? No, it's my initials. And I was one of the first people to get a license plate vanity in the state of Illinois. And I found out from this rep that at that time, the license plates were made in a prison in New Jersey. And years later, they finally got them made in Illinois. But back to that problem. Sorry about the sidetrack, but all right. So the neutralization constant equals hydronium times hydroxide equal 1.0 times 10 to the minus 14. In the first step, we want to convert from hydroxide concentration, OH minus, to hydronium, H3O plus. How do we do that? Use this equation, which I just told you, the ionization constant of water, KW. No, not me. But anyways, well, at least now you know my license plate number. In order to solve for hydronium, we want to get rid of hydroxide because we've got H3O plus alone on one side. Anything divided by itself becomes the number 1. How do you like that? I can do it at the same time. Am I good or not? Don't answer that. And whatever I do to one side, I do to the other. Anything divided by itself becomes the number 1, is gone. Hydronium equals 1.0 times 10 to the minus 14 divided by hydroxide. Put that number in, and you get this number, 1.0 times 10 to the minus 11. Are we done? No, we're trying to get pH, and we only have the hydronium. But second step, hydronium to pH, pH equal minus log of the hydronium. Here we put in the hydronium. When it's 1.0 times 10 to the minus x, the pH is x, in this case 11, and that's above 7, so it's basic. If I look at the clock, this would be a good time to take a 5-minute break. I can get up and walk around and stretch. And hopefully you do something too that makes you feel better. And I'll see you in 5 minutes, or give or take a minute. See you then. See you in 5. Let's try that again. I didn't have my mic on. I'm back. All right, quick thing. I may go a little over today's time, so I want to finish the organic. So if you can't stick around, you can still watch the video. And I was just thinking, after I was doing my stretching and everything, we only have 2 more weeks left in our summer. Boy, did it go fast. Hopefully you're having a good time. I am. All right, we're doing the Chapter 7 practice problem answers. And let's go through once again. Let's look at number 9. Number 9. Those who ever saw the Woodstock film, never mind. All right. If a solution has a hydroxide concentration of 1.0 times 10 to the minus 11, what's the pH of the solution? And is it basic, acidic, or neutral? And once again, you need 2 steps. And step 1, we go from hydroxide to hydronium. How do we do this? We use this formula. Where do you get this formula? Important information, test number 4. The hydronium times the hydroxide equals 1.0 times 10 to the minus 14. And you can solve for hydronium because you're given hydroxide, OH minus. And how do you do that? I want to get the hydronium, OH3 plus, on one side. I divide by hydroxide because anything divided by itself becomes the number 1. And whatever I do to one side, I do to the other. This cancels out. I'm left hydronium equal 1.0 times 10 to the minus 14 divided by hydroxide. Put in that value, which we figured out here. And that's 1.0 times 10 to the minus 3. Are we done? No, we want the pH. We have the hydronium. And by now, hopefully you know, step 2, we go from hydronium to pH. pH is minus the log of hydronium. Put that number in, we just calculated it. When the H3O plus hydronium concentration is 1.0 times 10 to the minus X, then the pH X is X, or the pH is X. How did I mess that up? Don't know. But anyways, in this case, X is 3, so the pH is 3. And in case you forgot, not my license plate number, but you should know the scale, pH scale, from 0 to 14. At halfway 7, that's a neutral solution. Below 7, it's acidic. Above 7, it's basic. Oh, by the way, remember your stomach's acidic because it has a pH much less than 7, and it's got water and acid in there, which makes it acidic. One of the miracles of life is we all have cells in our stomach that make hydrochloric acid. Oh, it still boggles my mind. See how my mind is boggled? I don't know, does that look boggled? It was. Oh, it's Bad Humor Monday. So pH less than 7, 3 is acidic. Now, number 10, what happens? This is important. Read the question. To the numerical value of a pH of water at pH equals 7.0 if you add a few drops of concentrated sodium hydroxide solution. Now, the first thing you have to know is NaOH solutions, that's a base. And when you add a base, the pH increases. You're at neutral, you add a base, the pH increases, goes up. Now, what happens to that pH of a beaker of water at 7.0 if you add a few drops of concentrated H2SO4? Well, you have to know H2SO4, sulfuric acid, is an acid. And when you add an acid, the pH decreases. How do you know that? Because you know the scale. When you're at 7, you add an acid, the pH decreases, goes down. You could have put goes down, or even written an arrow there down, would be all acceptable answers. All right, let's look at number 11. What happens to the numerical value of a pH of a beaker of a buffer solution? That's important. That's why I have the arrow pointing it out. If you add a few drops of a dilute acidic solution, by definition, a buffer solution resists change in pH. You add a small amount of acid or base. And a few drops of a dilute acid is a small amount, so the pH stays the same. B, you add a few drops of a base solution. Buffer solution resists change in pH. Therefore, the pH stays the same, does not change. All right, let's look at number 12. If you have 1.35 times 10 to the third milliliters of a 1.53 capital M NaOH solution if you have to add to neutralize 1.87 times 10 squared milliliters of an aqueous solution, what is the molarity of the solution? Well, as soon as you see the word neutralize, or if you see pH indicator, you know this is a titration. And important information, test number 4, at neutralization, moles of acid equal moles of base, milliliters of acid, molar times molarity of acid equal milliliters of base times molarity of base. Wrong one, right one. So at neutralization, first of all, we're trying to find molarity of HCl. We're given the milliliters and the molarity of the NOH. We're given the milliliters of the HCl. And here we have moles of base equal moles of acid, which for this case, for monoprotic acid and base, which I'll ever use in this class, which is my gift to you, milliliters of base equal mole times molarity of base equal milliliters of acid times molarity. We put those numbers in. We're trying to solve for molarity of acid. In order to get rid of or get that alone on one side, I divide by this number, 1.87 times 10 squared milliliters. That cancels out. But whatever I do to one side, I do to the other. And this cancels out. I'm left with molarity of HCl equals this, milliliters divided by milliliters. I'm left with molarity. And the answer is 11.0 or 1.10 times 10 to the first molar HCl. This is 3 significant, 3, 3, answer 3 significant figures. Oh, let's do 14. If you have to add 358 milliliters of a 5.67 molar HNO3, nitric acid solution, to neutralize 358 milliliters of a aqueous KOH solution, what's the molarity of the KOH solution? We're trying to find the molarity of KOH, which is a base. We're given the milliliters of that base. We're given the milliliters and molarity of that acid. At neutralization, moles of acid equals moles of base, which for a monoprotic acid and base, which these are, it will always be in my class and test and final, test. Anyways, milliliters of acid times molarity of acid equals milliliters of base times molarity of base. Where did I get that? Important information, test number 4. The moles of acid equals the moles of base. That's milliliters of acid times molarity of acid, equal milliliters of base times molarity of base. And now we go back and we put in the numbers. Here's the milliliters of base, molarity, acid, molarity of acid, milliliters of base, and we're trying to find the molarity of the KOH. We want to get rid of the milliliters KOH, divide by that. Whatever you do to one side, you need to do the other. KOH equals this. I rewrite it. You don't have to, but I do, because I like to. And good habits I don't break or change. And milliliters divided by milliliters cancels out. Notice these are both 350, and you get 5.67333 significant figures. And that's the acid and base chapter 7 practice problems. Any questions? I'm listening. Actually, the speaker's up there, not my monitor. All right, let me close a few things. And now let me open something up. All right, we're talking about organic chemistry. One of the things I asked you to learn how to do, and know this. Oh, I better be subtle. And that's how to draw organic molecules. Now I have the condensed with parentheses. I'm not going to ask you to do that, but you should know how to draw condensed structures. In other words, put in hydrogens. So if I ask you, oh, I'm drawing them in for you. No, you're supposed to do it. And the question is, draw on the hydrogens in A, 3 points each. How do you know how to do that? Carbon should always have 4, 4, 4. Yes, 4, 4. Does it look like it's coming to you? 4 bonds to carbon. And this is something you should remember. There's always 4 bonds to carbon. And if there isn't, you put in hydrogens. This carbon has 1 bond. 4 minus 1 equals 3. So I'll put in 3 hydrogens. This carbon has 1 bond. This right here. And there should be 4 bonds to carbon. 4 minus 1 is 3. And same thing here. Only 1 bond. So if I look at this carbon right here, how many bonds to carbon does that have? Well, this one, 2, 3. Carbon should always have 4 bonds to it. 4 minus 3 is 1. So there's 1 hydrogen there. And finally, this carbon, I have 1, 2 bonds. Carbon should always have 4 bonds to it. 4 minus 2 equals 2. So there's 2 hydrogen. And that's how you do it. You know something? I haven't shared the fun all afternoon. And there's some fun for you. Let's do one more. Draw in the hydrogens in molecule B. Your turn to have fun. Oh, looks like everybody's done having fun, so it's my turn. We look at each of these carbons, this one, this one, this one, this one, and this one. They all have 1 bond to it, 1 line. There should be 4 bonds to carbon, 4 minus 3. Each of these has 3 hydrogens, and this is how you draw it. Now, if we look at this carbon, it has 1, 2, 3, 4. Well, 4 minus 4 equals 0. That's why you don't put a hydrogen there. Now, if we look at this carbon, it has 1, 2, 3 bonds to it. 4 minus 3 equal 1. Isn't the math hard during this part? And therefore, it has 1 hydrogen. And finally, we have 1 more carbon to go. I just wiped out a carbon. I better put it back in. And that's this one. And there's 1, 2 bonds to it. There's always 4 bonds to carbon. 4 minus 2 tells me there should be 2 hydrogen. And that's how you do it. By the way, that's the number 2. All right, let's continue on. Now, for a polygon or for a ring, which are represented by polygons, poly, many-sided, each bend in a line is a carbon. Now, I am not doing all the line drawing. Each end of a line is a carbon. Each intersection of a line is carbon. And hydrogens are not shown. All right, so the question is 3 points each. How many carbon atoms are in A? Well, how do you do this? Well, you count in the ring, bends in a carbon in the ring. Each bend is a carbon. 1, 2, 3, 4, 5. And then you have these two, you see, 6, 7. So the answer is 7 carbons. And let me give you one to try. By the way, my software does a much better job. And how many carbons are in that molecule? Your turn to have fun. And I'll give everybody time to finish. Oh, by the way, tomorrow, don't forget, is National Turn On Your Webcam Day for your instructor. Not really, I just made up that holiday. All right, let's do it. Question is, how many carbons are in the B? Count every bend in a line in the ring is a carbon. 1, 2, 3, 4, 5, 6. Outside the ring, but attached to it are carbons. 7, 8, 9, 10, 11. And the correct answer here is 11 carbons. Remember, every bend in a line in a ring is a carbon. And I should tell you, who is the greatest? Ooh, I have a question. Hold on. Nope, somebody had the right answer. Thank you. I should ask you, who's the greatest of all organic chemists? And time's up. It's Mother Nature. By far, the things she's come up with are truly amazing. Great organic chemist. And Mother Nature and Dr. White love rings. All right, let's continue on. Let's talk about functional groups. Now, what is a functional group? I'll never ask on a test. It's a specific group of atoms in a molecule, and they undergo the same type of chemical reactions, whether they're in this molecule or this molecule. And switches off partially for this slide. There are different key functional groups. In organic chemistry, the basis of organic chemistry is the study and understanding functional groups initially. And how can you tell a functional group? Look for what's different. What's not a carbon atom or a hydrogen atom or carbon-carbon single bond is going to be a functional group. And that's where the fun happens. Now, switch is totally off, and Dr. White's going to have some fun himself. A double bond. Oops, wrong color. Still wrong color. Sorry about that. Let's try this again. Is two bonds, covalent bonds between two carbons. And that's a double bond. That's called a functional group. Let me show you something. Organic chemistry is in your daily life. Really? Yes. You're talking to organic chemists. There's a molecule called beta carotene. And here's this line structure. Every bend in a line is a carbon. Every end in a line is a carbon. This is a big molecule. And you notice the line here, two lines, double bond, another double bond, another double bond, another one, more. I think there are 11 double bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I counted right, 11. This is beta carotene. You're probably asking a question, why is he showing me this? Well, this is the molecule responsible for the color of carrots. And if you see on your screen, you see a lot of pictures of carrots. And I like carrots. I hope you do, especially in soup. I love them in soup. But anyways, this orange color is due to beta carotene, this molecule. And this molecule, your body breaks down to another molecule that has the common name of retinol. And retinol, I bet you can't guess what part of the body uses retinol? Your eyes. And that's why rabbits have good eyesight. I don't know about that, or at least Bugs Bunny, because he was always eating a carrot. Now, while we're talking about double bonds, here's another molecule called lycopene. You don't have to write this down. And every bend in a line is a carbon. Every 2 lines is a double bond. It's got a double bond here, 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 here. Lots of double bonds. You're probably saying, why is he showing me this molecule? Good question. If you look on your screen, you see a tomato. And a tomato has that red color because of the chemical lycopene, a molecule which has carbon-carbon double bonds. Now, I could spend a lot of time, but I don't have it today, maybe tomorrow or next day. A triple bond is a carbon with another carbon with 3 bonds between it. An alcohol is a molecule with a carbon with, this is called a hydroxyl group. An aldehyde is a carbon bonded to a carbon with a double bond to oxygen, hydrogen. Now, sometimes we show it like this. Now you're on my home court. R is like in math, and X and Y is a number. R is just something with carbon and hydrogens. That's an aldehyde. Dr. White loves aldehydes. A ketone, I'm not putting in the hydrogens, is a carbon double bond oxygen with carbons attached to it, no hydrogen, sometimes shown like this. And Dr. White loves ketones. I did my PhD thesis on aldehydes and ketones. Another one is, and I'll use the R group, carbon double bond to oxygen with an OH group. This is a carboxylic acid. If you take this off, and by the way, carboxylic acid you find in vinegar. And this is a carboxylate anion, and it's used for things like your bar soap. Now, an ester, again, switches off for this, is carbon double bond to oxygen with our group. That means carbon hydrogens and an oxygen here, and R prime more carbons. Now, amines, and I worked in amines, where R prime and R double prime can be hydrogen or can just hydrogens alone or carbon hydrogens, and that's an amine. Now, I have a number of US patents in this type of molecule, and this is called a quaternary ammonium salt, and the R groups are carbon, hydrogen, and they're 4 different. And this also has a plus charge on the nitrogen And all molecules have a net zero charge, so it also has an anion. Quaternary ammonium salts, they're fabric softener. Those in water are your fabric softener. I have a number of patents in fabric softeners. And it's also used as an antimicrobial compound. Time to gross you out. Are you familiar nowadays when you go into the supermarket or a big box store, they have some kind of dispenser with those little towelettes with a material on them, a liquid that kills bacteria. And it's also active against COVID-19. And here you see some of the different types you can buy uh, for your own house. And many years ago, before COVID, many years ago, I saw two different studies I read where some scientists went out to supermarkets and swabbed down the handles and the seat area and the parts of the cart where a baby sits, especially the handles. And they came back and found about, are you ready for this? It's going to gross you out. 85% of the carts they tested, 85% had fecal material. Yep, fecal material. Yeah. And ever since I read that, whenever I go into the supermarket or a big box store or can get a cart, I get a couple of those, wipe the handle, wipe the whole baby seat area. And that way, and then I wipe my hands with a fresh one because 85% with fecal, but it's true. All right, let's get back. The functional groups. And one last one is an amide that looks like this. Remember, R can be anything with carbon and hydrogen, same thing with R and R prime. But in this case, R prime and R double prime can be hydrogen or just carbons and hydrogen. And all your protein are amides, amino acids held together as amides. All right. Settle time. Hint, know this. How do you find a functional group in a molecule? You look for something different. Anything that's not a carbon atom, a hydrogen atom, or carbon-carbon single bond is going to be a functional group. And that's where all the fun is. That's where all the action happens in a molecule. So, how do you find a functional group? Look for anything that's not a carbon atom or a hydrogen atom or a carbon-carbon single bond. And let's look at a question. Circle a functional group or groups, 3 points each. So how do we do that? We look for something that's not carbon or hydrogen. Ooh, oxygen here with a hydrogen on a carbon, that's a functional group. It's called an alcohol, but I'm not asking you to learn that. You take 1212 with me, organic chemistry, then you also have to learn the names and a lot more. Ooh, carbon with 2 oxygens. And here's another functional group, and that's a carboxylic acid. So look for what's different. What's not a carbon hydrogen, carbon atom, or hydrogen atom, or carbon-carbon double bond, single bond. Let me say that again. What's not a carbon atom, hydrogen atom, or carbon-carbon single bond should get your attention like that. I'm going to let you have some fun. I can give you 2 of them. And why don't you have some fun? Circle the functional group, 3 points each. Your turn. Remember, look for what's different, what's not hydrogen, what's not carbon, what's not a carbon-carbon single bond should get your attention like that. And please be patient. I try and give everybody time to finish. All right, my turn. Have fun too. So you look for what's different. Now, these are carbon, hydrogen, and single bond carbon. Ooh, a double bond. 2 lines, double bond, 3 lines, triple bond. That's called an alkene. It's a functional group. Carbon, ooh, carbon with an oxygen. And this is a ketone. And we're done because the rest of the carbons have hydrogens and are just in single bonds. Now, if we look at C, remember each bend in a line is a carbon. This is a double bond. Ooh, 3 lines between 2 carbons, triple bond, single bond, single bond. Ooh, oxygen, that's not carbon or hydrogen. And this is an aldehyde. And that's how you play that fun game. Circle the functional group, 3 points each. But you didn't know we had fun games. And we just did our functional group practice time. Now, one of the things, I may be rushing through this a little quick, but tomorrow and especially Wednesday, I have time to go back and we'll practice more of the organic and also the acid-base stuff. So you'll do good on test 4 if you've done the practice problems on your own. Now, this switches off on this slide, but I just wanted to teach you about a special functional group that stinks. When I say stinks, I mean stinks. And that's called a thiol. And a thiol is called the sulfur analog of an alcohol. And that's where you have carbons attached to a sulfur with a hydrogen on it. And these stink. Now, thiol is the ending, forget about the nomenclature, and they stink. Now, the old name until about 1980s or early 90s, which is not that long ago, I was already working in the chemical industry. Oops, yep, I've been around that long. Was called the mercaptan, which I sometimes still use. Now, when I say stink, what do I mean stink? Well, they're responsible for the odor of onions and garlic. That's due to thiols. Now, what's the most stinkiest thing you can think of? A skunk's defensive weapon, a skunk scrape. And somebody took the time to analyze what is in a skunk spray that, when an animal gets skunked, or a person, oh, it's awful. I haven't, but you drive by the road and you smell one. Oh, what's that stink? Skunk let loose. Well, it's 45% this thiol. There's a double bond, and every bend in the line is a carbon. And here's the SH group on a thiol. And this thiol. And notice that adds up to 70%, and the remainder is water. Now, I have a very sad story to tell you that you should know about. And this is where organic chemistry and knowledge of physical properties, odor is a physical property of thiols, they all stink, help. Now, back in about 1935, and by the way, click switches off, but I still want you to learn about this. In a city, a small city in Texas, there is a tremendous, awful explosion in a school. And it killed about 135 students and teachers, and it injured many, many others, badly burned. And what happened? This was almost a brand new school. Well, it turned out there are two versions of it, but one version is whoever put in the gas pipes for natural gas, they leaked. And after a while, that school filled up with natural gas. What you don't know is, you can't see it, but there's a light switch right there for my room, part of the lights in my office here. When you go like this on a regular light switch, there's a little spark in there. When you turn on your house, anything electrical that's connected to alternating current, the wall plug, guess what? There's a spark. And that spark, if you have enough methane, which is explosive, will detonate it and cause a bad fire. And that's what happened. Sad but true. You're saying, Dr. White, why couldn't they smell the gas leak? Because back then, they didn't put a thiol, which they now do in natural gas, the methane you use to cook with, or heat your water heater, or heat your house in the winter. I think just about everybody in Northern Illinois has natural gas furnaces in their house, condo, or apartment building. And because of that tragedy, terrific, awful tragedy, the state government of Texas back in 1935 had a commission. That commission said, to make things safe for everybody, let's add something to natural gas that you can smell a leak. Because methane, CH4, has no odor at all. And what they added was a thiol, T-butyl thiol. Now, T-butyl thiol stinks, really stinks. How bad does it stink? Well, they only put about 1 to 4 pounds of T-butyl thiol. Are you ready for this? In 1 billion pounds of methane, natural gas, to make it stink the way it does. And that's pretty stinky. So you only need a little amount. That's called 1 to 4 parts per billion are in your natural gas. But if you've ever smelled a gas leak, and I have, you can smell it real good. Now, in organic chemistry, there are general reactions, and these reactions always occur 99% of the time with certain types of functional group and molecules. And I'm going to ask you to learn some. But if I look at the clock, I'm going to go a little later today because I want to finish. Well, you know something? I think we're doing okay. And tomorrow I just have my review and then we'll do that. What we'll do tomorrow is we'll finish up organic. I will do my review. Then Wednesday, we'll come back and do the practice problems for organic. We'll do a lot more practice with organic and maybe a few more pH problems. And with that, I think I'm going to call it a day today. We're on schedule just about. And with that, I'll say, 1, don't forget, hand in your labs. Looked at the schedule. Tomorrow's the last lab. I hear everybody saying, yay. But anyways, hand in your labs. Remember, a week from tomorrow is the end of the amnesty program. After that, any labs you haven't handed in, you'll get a 0. And that's not going to help your grade. And I don't want to do that, but you don't hand in the labs, I have to do that. And don't forget, test number 4 is coming up this Thursday, and I'll do my review tomorrow for test 4. I think I'll do the finish organic and then do the review. With that, I'm done for today. Have a nice rest of the day. I'll see you tomorrow. Kein gesund. Goodbye now.